In this video, we're going to create some data frames. A data frame is used to store data tables. It's a list of vectors of equal length. Let's start by creating one that consists of some numbers. So we'll create a vector of numbers, a Boolean vector, and a list of letters. Now notice that each of these vectors is of equal length, so I can create a data frame with them. So I'll use the data.frame command. And this data frame will be n, it'll be bool, and it'll be l. And we can see our data frame f is up here in our environment tab. We also have this handy little icon that we can click on, and it'll show us our data frame. So we've got a column vector of numbers, a column vector of bools, and a column vector of letters. We can access elements in this data frame the same way we would access anything else. If we want row 2, column 3, we talk about f square bracket 2, 3, and we get b. We can see up here that indeed that's b. If we type in f 3, 2, that's row 3, column 2, and so that's false. Row 3, column 2 is right here. Now R has a number of built-in data frames that we can use, and we're going to take advantage of them right here. One that we're going to use today is the PlantGrowth data frame. This is built in, so there's nothing that you have to import. So we're going to call this df, and then just start typing in PlantGrowth, and it should pop up. So again, we've got a data frame here in our environment tab, and we can click on the little icon to see, in fact, what's going on. So it says that there's 30 entries and 2 columns. If we want to know what's going on in this data frame, or in this data set in particular, we can use the help command and type in help PlantGrowth. And in our window down here, we get a little write-up on the data set. So it's a result from an experiment on plant growth. The results of an experiment to compare yields as measured by a dried weight of plants obtained under control and 2 different treatment conditions. We can access this by using the word plant growth. It is a data frame of 30 cases with 2 variables. Variable 1 is the weight, it's a number. The levels of the factor group are CTRL, standing for control, TRT1, which is treatment 1, and TRT2, which is treatment 2. So we get a tiny data dictionary here, a nice source, in Introduction to Statistical Modeling by Dobson, and then a few examples at the bottom. So let's actually take a look at this data set ourselves. One thing that we might want to know about this data set is how many rows and columns it has. We already know that it has 30 rows and 2 columns, but in case we didn't, the nrow command will tell us that indeed it has 30 rows, and ncol will tell us that indeed it has 2 columns. If we'd like to reference the first column, all of the weights, we use df square square 1. All of the second column, data frame square bracket 2, will give us all of the elements in the second column. If we want to access just a certain few rows, then we can use single square brackets. Let's say we want to get the first 5. So we create ourselves a nice vector saying that we want the first 5 rows, a comma indicating that we want all of the columns. So there we go, the first 5 rows of the data frame. If we want everything except the first 5 rows, we just use a negative in front of our C vector. And you can see here that we have everything from row 6 through row 30, everything except for the first 5 rows. Now let's say that we wanted only the results from the control group. R understands this type of logic. So if we type in df $group, so we look at the group column, and if we set that equal to control, or we look to see if that's equal to control, we're going to get a vector of trues and falses indicating whether the group is equal to the control group. Now, if we only want to access data that's in the control group, what we want is rows for which the value of that previous logical statement is true. So we want to keep all of the rows for which this is true. So I'm going to make a variable keep. And that's going to be this vector where the group column is equal to control. And then we're going to look at the data frame, but only the rows where the keep value is true. And you can see here that we get a nice group of 10 results, all of which are in the control group. If we want to keep observations that are, say, of a certain weight, maybe we want to keep the big results. So I'm going to create a logical vector big, and that's where the weight, df $weight, is greater or equal, let's say, to 5. And if we look at the data frame with only the big values, here's what we get. And you'll notice every one of those weights is at least 5. So this might help you if you want to figure out, for example, how many big observations are in the control group, how many big observations are in treatment 1, how many big observations are in treatment 2. And if you look at this very quickly, you can see that there's 1, 2, 3, 4, 5, 6 that are in the control group, 2 that are in treatment 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 that are in treatment 2. So using logic like this can help you sift through your data and come up with some very quick preliminary conclusions. We're going to be using data frames the rest of this package, and we'll get some close looks at some very commonly used data sets